Anybody knows what a factor is? Like, have you ever heard the word factor, multiples, anything like that? Does anybody know what a factor is? Yeah, Soraya, what do you think it is?
Miss factors is like when like factors is like the numbers multiplied to make another number.
All right, give me an example.
Like a factor of 12 is 6
Correct. Good.
and 6
So,
times 2 is 6.
yeah, correct. A factor is a number that goes into another number. Thank you, Soraya. That goes into another number without leaving a remainder, right? So a factor is a number that goes into another number without leaving a remainder. So like Soraya said, without leaving, I don't know why I choose to explain this with the most number of words, because I could have just said that it divides completely into the next number, right? So some examples would be like the factors of, I think Soraya said 12 just now. So the factors of 12 would be 1, 2, 3, 4, 6, and 12. Those are all factors of 12 because they can all go into 12 without leaving a remainder. So in the same way that numbers can be factors of other numbers, you can also have algebraic factors. So for example, if you have like let's say you have 4x, 3x, and 10x, right? They all have a common factor, which is x, right? They all have that common factor of x. Because, well, I liked how Soraya explained it just now. She said a factor is a number that when you multiply by another number, you get the another number. In terms of like 2 is a factor of 12 because when you multiply 2 by 6, you get 12. 3 is a factor of 12 because when you multiply 3 by 4, you get 12, and so on, right? So x is a factor of 4x, 3x, and 10x because, well, 4x is 4 times x, 3x is 3 times x, and 10x is 10 times x. So we can say that the common factor here sorry, 4x, 3x, and 10x is x. X is a common factor, right? Because x can be divided into any one of those numbers. So x is a common factor of all of those, right? So just like with regular numbers, how you would use factors like factors of 18, for instance, would be 1, 2, 9, and 18. Similarly, you can have algebraic factors, right? So one thing to note is the difference between a factor and a multiple. A factor is the number that goes into the other number, right? Multiples are numbers that you get when you multiply the number. So, for instance, if we use the factors of 4, so the factors of 4 will be 1, 2, and 4. But the multiples of 4 are 4, 8, 12, 16, and so on. So factors is a finite group. You could only have a certain number of factors of any number, but multiples is an infinite group, right? Because the multiples of 4 goes on and on and on and on. Unless I say something like list the multiples of 4 between 4 and 16, for instance, or all the multiples of 4 that are less than 30. Now it becomes a finite group. But if I just tell you to list the multiples of 4, it goes on and on and on. So multiples, unless you specify where you're stopping, it will be an infinite group or infinite group. However, factors is always a finite group, right? Because there's only a few factors, whereas there are lots of multiples. You can list the factors of a number, even a very, very large number. You can still list the factors of them. It might take long and it might have plenty, but you can still list it. However, it probably is impossible to list all, not probably, it is actually impossible to list all the multiples of any single number, right? So looking at algebraic factors now, like if I had, let's say I had xy, x squared, x, well, just x, and then 4x. So I have these four terms, xy, x squared, x, and 4x. As you can see, they all have right? So x is a factor of all of them, right? X is a factor of x squared because remember, a factor is a number that, well, a term in this case that could go into another term without leaving a remainder, or it is one that completely divides into that. So for instance, xy divided by x will just be sorry, would just be y, right? X squared divided by x. Well, remember, x squared is really x times x, right? So when you divide x squared by x, you'll end up with x. X could go into x one time, and then x could go into, so 4x divided by x is going to be 4. All right. So something to make a note of is when you multiply the factor by the quotient, you get back what you're looking for. What do I mean by that? Well, x into xy is y, and x times y, well, that gives me back xy, right? X times x gives me x squared. 1 times x gives me x, and then 4 times x gives me 4x. So when you multiply the factor by the quotient, right, you get back the original number that you're dividing by. So those are just some fundamental facts about factors, right? Um, what else? So let's look at some, oh, actually, last week we looked at expanding brackets, right? So we looked at if you had, for instance, if you had 7 by A plus 2B. To expand these brackets, you would say 7 times A, which will give me 7A. And then I would say 7 times plus 2b, which would give me plus 14b, right? So that's what we did last week. We looked at expanding the brackets. Now, this week, we're going to look at going from 7a plus 14b to the factorized form. So 7 times a plus 2b is actually the factorized form of 7a plus 14b. And why is that? Well, if I look at 7a plus 14b, the common factor here, well, when you're factorizing, look at the constant, well, the coefficient, sorry, and then look at the variable. So with 7a and 14b, the common factor here is 7 because 7 could go into 7a and 7 could go into 14b. So if I had to factorize this, I would take 7 on the outside, open brackets, and I say, well, 7 into 7a is a, since 7 times a is 7a, and then 7 into 14b is 2b, because 7 times 2b is 14b. So this week we're looking at going from the expression to the factorized form. Okay? So that's our whole thing. That's what we're going to look at today. So let's look at some examples. Factorize the following. Okay, so let's say I had 4x plus 4. Well, the common factor here is 4. So I take 4 on the outside, and in brackets, I'll put x because 4 times x is 4x, and then 4 into 4 is 1. So that would be the factored form, right? Um, if I had 6a plus 2, well, the common factor here is 2 because 2 goes into 2 and 2 goes into 6. So 2 on the outside and in brackets. Well, two things you could ask yourself. You could either say 6a divided by 2 is 3a, or you could ask yourself, well, 2 times what gives me 6a? 2 times 3a gives me 6a. And then 2 times 1 gives me back 2, right? So anyhow you want to think about it is fine. Either by saying 2 times what number times the factor will give you the original term, or the original term divided by the factor. Both of them are right. Okay, let's do another one. Let's say I had, uh, hold on. Right. 5a minus 10b. Again, the common factor here is 5 because 5 could go into 5a and 5 could go into 10b. So this would be 5 into, well, 5 into 5a is just a, and 5 into minus 10b will be minus 2b. Okay. Um, what about the 3t minus 9? The common factor here is 3, since 3 could go into 3t and 3 could go into 9. So I take 3 on the outside, and in brackets, it'll be t minus 3, since 3 times t gives me 3t, and 3 times minus 3 gives me minus 9. Okay, and then let's do one more. Let's say I had um 3x minus 12. Well, the common factor here is 3. 3x divided by 3 is just x. And then 12 divided by 3, well, this is minus 12. So minus 12 divided by 3 is minus 4. And there you have it. So I want you all to try some for me, please. Try these. Write these down. Make sure you write these down as well. And try these for me. 12x minus 6. 10a minus 5. 2a plus 4b. 4 plus 16x. And finally, 7 minus 14. So please try these for me. Send me a picture as soon as you finish. Okay, I'm going to do it, guys. So here, the first one, well, the first one that you had to do, number 6, you have 12x and 6. So the common factor between 12x and 6 is 6, because 6 could go into 12x 2x times, and then 6 could go into minus 6 1, right? Remember, to check if your answer is correct, you simply need to expand these brackets to make sure you get the same thing. So 6 times 2x is 12x, and 6 times minus 1 is minus 6. So you see, you get the same thing, it's correct, right? So make sure that that's how you could check your answer, okay? With 10a and minus 5, the common factor here is 5. 5 into 10a is 2a. And then 5 into minus 5 is minus 1. Again, to check your answer, you simply multiply your brackets, right? So 5 times 2a is 10a, and then 5 times minus 1 is minus 5. Next one, we have 2a and 4b. The common factor here is 2. So 2 into 2a is a, and 2 into 4b is 2b. Again, to check my answer, 2 times a is 2a, and 2 times 2b is 4b. The next one, 4 and 16x, the common factor there is 4. 4 into 4 is 1, and 4 into 16x is 4x. To check your answer, you multiply your brackets. So 4 times 1 is 4, and 4 times 4x is 16x, right? So far, as you can see, when you expand your brackets, you get back the original expression that you were trying to factorize. That's how you know you are correct. And then the last one here, the common factor is 7 because 7 could go into 7 and 7 could go into 14x. So 7 into 7 is 1 and 7 into 14x is 2x. Right? And now to expand the brackets to check if my answer is correct, I say 7 times 1, which is 7, and 7 times minus 2x is minus 14x. All right, so I hope that makes sense for you guys. All right. Okay, so let's look at when you have a term in like x squared or something. Okay, so let's see. Let's say we had x squared minus 7x. All right. Well, this would be, as you can see, the common factor here is x, right? Because x could go into x squared and x could go into 7x. So you put x here on the outside because that's the common factor. And x times x is x squared, and x times 7 is 7x. Pay attention to your signs. One thing, Josh, did you see? I think in yours, you had the correct numbers inside of the brackets, but I think you for some of them you changed the sign.
Yeah, miss.
Yeah, yeah, right. But I see that you got them correct, so just be careful with that. Okay, good. So x into x squared is x because x times x is x squared, and then x into 7x is 7. Cool. What about if we had um, hold on, x squared plus 2x. Well, this is very similar to the first one. Again, the common factor here is x. So will go on the outside. X times x gives me x squared, and x times plus 2 would give me plus 2x. All right, so this part you just have to be careful with your signs. Cool. So let's look at one more, and then I'm giving you all some to do as well. All right. So let's say I had 4t minus 2t squared. Now here you have a common factor, not just in terms of the variable t, but also in terms of the coefficients, because between 4 and 2, you have a common factor that is 2. And notice that when you're factorizing, guys, always use the highest common factor, right? So I'll show you what I mean afterwards. So between 4 and 2, the highest common factor there is 2. And then t can also go into 4t as well as 2t squared. So the common factor here will be 2t. 2t times 2 will give me 4t. And then 2t times t will give me 2t squared. Now, if this part is confusing you, multiply your brackets to see if you get back the original thing, right? So 2t times 2 will be 4t. And then 2t times minus t will be minus 2t squared. So you want to be careful with that, okay? Um, right. I was talking about using the highest common factor when you are factorizing. So let's say I had, um, let me see. Say I had 4t. Wait, oops, sorry. 4t 4t and 4t plus 8t squared. So with this, 4 and 8 have common factors of 1, 2, and 4, right? If I used 2 to factorize, this is what would happen, right? So it will be 2t on the outside. 2t into 4t is 2. And then 2t into 8t squared is 4t, right? However, as you can see, 2 and 40 still have a common factor. So this is not yet completely factorized. So I would have to factorize again, which would mean that I'll have 2t on the outside, and inside I would have 2 being the common factor there. 2 into 1 plus 2t, right? So this is going to give me, to remove these square brackets, I'll have to multiply 2t by 2, which would be 4t into 1 plus 2t. And that is the complete factorized form. Because when you're factorizing, what is in your brackets cannot have any common factors. If you have factorized and within your brackets you still have common factors, it means that you have not completely factorized. You need to factorize again. However, all of this can be avoided if you simply use the highest common factor to begin with. So in the event of 4t plus 8t squared, the highest common factor between 4 and 8 will be 4 because 4 could go into 40 and 4 could go into 8t, right? So the common factor here will be 4t. 40 into 40 is 1, and 40 into 8t squared will be 2t. So you see how in the end, I still got the same answer, right? But it was one step to factorize here versus two steps to factorize when I used just a common factor. So it's always, when you're factorizing, always choose the highest common factor to avoid any room, to avoid any error. All right. Or to just avoid, it's not even an error, it's just that to avoid having to factorize twice, right? So to completely factorize, you need to use the highest common factor. Okay, guys, I want you all to try some for me. Try these, please. Remember, to check your answer, you simply multiply out your brackets to see if you get the original question that you were working with to begin with. And write down all the examples as well. Okay, guys, so try these. Send it to me when you're finished. This work is looking pretty good. So the first one, I'm still gonna do it, right? A squared plus 6a. The common factor here is a. So a times a is a squared, and a times 6 will give me 6a. Then we have 2x squared plus x. The common factor here is x. X times 2x gives me 2x squared, and x times 1 is x. B squared plus 4b. The common factor here is b. B times b gives me b squared, and b times 4 is 4b. Number 8, the common factor here is 5x. 5x times 1 is 5x, and 5x times 2x is 10x squared. With 16 and 24, what is the highest common factor there? That's 8, right? So it'll be 8a. Then 8a into 16a is 2, and 8a times minus 3a will give me 24a squared. And finally, 15y is the common factor between 15y and 30y squared. 15y times 1 is 15y, and 15y times minus 2y gives me 30y squared. So far your work is looking good. I think everybody gets the hang of it. The only thing that you guys have to be a little more mindful of is using the highest common factor, right? So like for this one, 16a plus minus 24a, some of you used 4, and it's fine. You could do, it'll be 4a into 4a minus 6, sorry, not 4a, sorry, 4a into 4 minus 6a. But then 4 and 6a have a common factor. So this would actually be, well, you keep 4a on the outside and you factorize 4 minus 6a, which will end up being 2 by 2 minus 3a. And then you remove your square brackets by multiplying 4a throughout. So it'll be 4a times 2, which will be 8a by 2 minus 3a, which is the correct answer, but which obviously is more work than just using 8a to begin with. Okay. Right, let's look at some that have more than one term. All right, so let's say we had uh 9a plus 12bc. All right. So the common factor here, there are two things you have to look at. First, your coefficients, 9 and 12, and your variables a, b, and b, c. So the common factor, the highest common factor between 9 and 12 is 3. So the coefficients will be 3. And then between a, b, and b, c, the common factor is b. All right? So 3b times 3a gives me back 9ab, and 3b times 4c gives me back 12bc. So my factorization here would be 3b into 3a plus 4c. So do it like piece by piece in terms of looking at the coefficients to see what is the common factor among the coefficients, not just any common factor, but the highest common factor between the coefficients, and then the variable terms, what is the common factor there as well. All right, so let me show you one more, and then I want you all to try something like that, and we'll take a short break afterwards. Okay, so this is number one. Um, let's say I had A, B, oh, 5xy minus 10z. The common factor, first I look at the coefficients 5 and 10. The highest common factor between 5 and 10 is 5. And then between xy and xz is, so 5x times y will give me 5xy, and 5x times minus 2z will give me minus 10xz. All right, so same principle, guys. It's just that you have to use it piece by piece. Okay, so you try these for me, please. Write down the examples, huh? Oh, and also you could have more than two terms. You could even have three. The same principle applies in that you're using you're using one common factor among all three. Pay attention to your signs as well. Okay, try these for me, please. Now, the ones that have three terms, the common factor has to be a factor of all three terms. It cannot just be a factor of two of them. It has to be all three. Right. So the first one, 3y squared plus 27y. The common factor here is 3y. 3y times y gives me 3y squared, and 3y times 9 gives me 27y. Now, in number 4, you have 2x squared, 4x, and 6. As you can see, all of them do not have x, so x will not be part of the common factor. However, 2, 4, and 6 all have the common factor 2. So I could put 2 on the outside as the common factor. 2 times x squared gives me 2x squared. 2 times 2x gives me 4x, and 2 times 3 gives me 6. All right, so it has to be the common factor here would only be 2 because all three terms do not have x. In number 5, all three terms have b, so the common factor here is b. B into AB is A times A is AB. B times 2C is 2BC. And B times D gives me BD. In number 6, the common factor, the coefficients 5, 4, and 3 do not have any common factors other than 1. So the common factor here will be x, since all of them have x. So x times 5y gives me 5xy. X times 4z is 4xz. And then x times 3 is 3x. The number 7, you have 2 as a common factor because 2 could go into 2x squared, 4yz, and 8yw. So the common factor is 2, and then among the variables, y is also common. So 2y into x minus 4z, since Sorry, not 4z. Sorry about that. So it's 2y times x will give me 2xy. 2y times 2z gives me 4yz. And then 2y times 4w will give me 8wy. Or 8yw, right? And then the final one, the common factor here is only 4, since all of the three terms do not have a. So 4 times a squared is 4a squared. 4 times 2a is 8a. And then 4 times 1 is 4. All right, guys. So these are the answers. Make sure you copy them down if you didn't get them already. And at this point, we're going to take a short break. So with factorizing by grouping, you basically divide the terms into two pairs and then you factorize, right? So for example, if I had, let's say I had ax plus ay and then that plus bx plus by, right? So let's say I have to factorize this term, well, this expression, ax and ay plus bx plus by, right? So as you can see, all four of them do not have common factors, right? But if I were to group them into two pairs, I can group them in such a way that they'll have common factors. Each pair will have a common factor. So here's what I mean by that. If I look at it as this as one pair, ax and ay, then the common factors here between ax and ay will be a, right? Because a could go into ax and a could go into ay. So factorizing ax plus ay would be a plus a by x plus y, right? Since a times x is ax and a times y is ay. And if I were to factorize this pair, well, the common factor there is e, right? So I'm going to bring down this plus sign, right? Because you can't get rid of that. So I'm bringing down that plus sign and I'm going to factorize bx plus by. The common factor between bx and by is, so b times x will give me bx and b times y will give me by. So now I have factorized both pairs. First, I got a by x plus y and b by x plus y. Now, as you can see, guys, I have x plus y and x plus y. So that is the repeated factor. So you got to look for your repeated factor. And the repeated factor here is x plus y. So I'm going to put x plus y, my repeated factor, and what will go in brackets will be e plus e. Because if I were to factorize a by x plus y, right, if I were to divide a by x plus y by that whole factor x plus y, look what would happen. It would cancel, right? Because x plus y times a, well, that would give me a by x plus y. And similarly, x plus y times b will give me b times x plus y. So the repeated factor x plus y is the new factor of a by x plus y and b by x plus y. All right, so here are some things that you need to look for when you are factorizing by grouping. Firstly, you split up the entire expression into two pairs, two pairs that have a common factor in each. So with ax plus ay and bx plus by, I split it up into ax plus ay and bx plus by, since ax plus ay has the common factor a and bx plus by has the common factor b. All right. So then I factorize them individually, each pair individually, to get a by x plus y and b by x plus y. The key here is to look for that repeated factor. The repeated factor is what is in brackets. It has to be the exact same terms with the exact same signs. So it's going to be x plus y. Even if it was y plus x plus y and y plus x is the same thing. It's the same terms with the same signs. So you're fine to go there. right? Now, in this same example, I could have grouped it differently, yeah? I could have said, well, with ax plus ay, um, plus the bx plus by, I could have actually grouped it where I have the x's together, the terms with x's, and the terms with y's together. So I could have done ax plus bx as my first group, and my second group would have been ay plus by. And now factorizing them by grouping, meaning I'm factorizing these first two and these the second two here. It'll be the common factor between ax and bx is x. So x times a gives me ax and x times b gives me bx. Similarly, when we bring down this plus sign, the common factor between ay and by is y. So that would be y times a is ay and y times b is by. So now you see I have my repeated factor a plus b. So that comes out here. A plus b times x will give me x by a plus b. And a plus b times y gives me y by a plus b. So it doesn't matter, right, how you decide to group your your expression, sorry, your terms in your expression. It just matters that you group the terms that have like terms together, right? So sometimes it's written exactly in the order that you need to that you could work it out, but in other times you might need to actually rearrange the expression. So just write in the terms next to each other that have the same factor, right? Let's do another one. Let's say I have xy plus 2x plus 3y plus 6, right? So here I am going to group xy plus 2x and then 2y plus, sorry, 3y plus 6, right? Between xy and 2x, the common factor is x. So in brackets, I will have x times y gives me xy, and x times 2 gives me 2x. So this would be the first factorization. The second factorization, I'm bringing down this plus sign. Your sign is important, by the way. The common factor between 3y and 6 is 3. And then factorizing 3 times y gives me 3y, and 3 times 2 gives me 6. So my common factor here, my repeated factor, as you can see, is y plus 2. So I put that first. Y plus 2 times x gives me x by y plus 2. And and then y plus 2 times 3 gives me 3 by y plus 2. And that would be my that would be my factorizing by group in there. All right. Um, Again, you could have grouped it differently. So like you could have grouped it like, I'm just going to write it over, right? It was xy plus 2x plus 3y plus 6. Now, if I grouped it differently, I could have grouped the terms with y first and then the terms with x. Well, the terms with 2 and 6 separately. So I could have had xy plus 3y plus 2x plus 6. And doing it this way, I would have to group the first two terms and the second two terms. The common factor between xy and 3y is y. So in brackets, I will have y times x is xy and y times 3 is 3y. And now my plus sign, the common factor between 2x and 6 is 2. And 2 times x is 2x and 2 times 3 is 6. So as you can see, I have the repeated factor x plus 3. So that's the common factor now. X plus 3 times y gives me y by x plus 3. And x plus 3 times 2 gives me 2 by x plus 3. So as you can see, guys, you still get the same answer. Now, the order of the factors does not matter because if you think about it, 3 times 2 is the same as 2 times 3. Remember, factorization literally means multiplication. So factors, sorry, what you get when you multiply two numbers by each other, in this case, to get back your original expression. So it doesn't matter what is in the brackets, sorry, the order of the brackets. It does matter though, the signs inside of the brackets. Okay, let us do another one. Let's say we had, um, let's see, xy plus 3x plus 3y plus 9. All right. So I'm not going to rearrange it because it's already in an order such that they have common factors, right? So xy and 3x, they have a common factor of x, and 3y and 9 also have a common factor that is 3. So factorizing by grouping, common factor here is x, so x goes on the outside. X times y is xy, and x times 3 is 3x. Bringing down this plus sign here. The common factor between 3y and 9 is 3. Now 3 times y gives me 3y, and 3 times 3 gives me 9. So I have my repeated factor, same terms and same signs in the brackets. So this would be y plus 3, and you put the remaining terms as well in your in brackets, right? And actually, if I were to put this in the same color just to emphasize it, that it's the same thing up here, y plus 3. Okay, let's do another one. Right, so a plus ab plus 2b plus 2b squared. Again, I don't need to rearrange it. It's already written in such a way that they have common factors, right? So I'm looking at a plus ab, I'm factorizing that, and then I'm factorizing 2b and 2b squared. So the common factor between a and a plus b is, sorry, the common factor between a and ab is a. So a times 1 is A, and then A times B is AB. Bringing down this plus sign. The common factor between 2B and 2B squared is 2B. Brackets, it would be 2B times 1 gives me 2B, and 2B times B gives me 2B squared. So my common factor there is 1 plus B. Right? And in brackets, you'll have, well, 1 plus b times a would give me back this first expression, and 1 plus b times 2b will give me 2b by 1 plus b. All right? Another one, let's say we had a squared plus ab plus ac, sorry, plus bc. So again, it's already written in such a way that I could factorize by grouping without rearranging the expression. So the first one, between a squared and ab, a is the common factor. And the factor, in brackets, you'll have, well, a times a is a squared, and a times b is ab. Bring down this plus sign. The common factor between ac and bc is c. In brackets, you'll have, well, C times A is AC, and C times B is BC. So finally, that would be A plus B, right? Well, A plus B times A will give me back this first expression, and A plus B times C will give me back the second expression. All right, guys? These brackets there were just for explanation purposes. You don't need that in your solution. Could put it if you want, but it's not actually part of the solution. Okay, so I want you all to try some for me. Please try for me number 4, xy minus 3y plus, actually, I'll do this one with you guys because as you notice, I have different signs here. All the ones before, I just had positive signs, but this one I have a mixture of both positive and negative signs. So in this case, you're still gonna factorize by grouping. So I'm factorizing x, y, and 3y first. The common factor here is y. So in brackets, I will have, well, y times x is xy, and y times minus 3 is minus 3y. I'm bringing down this plus sign here. The common factor between 2x and 6 is 2. In brackets, I will have, well, 2 times x will give me 2x, and then positive 2 times minus 3 will give me back minus 6. Notice the signs. This is the part that students find the most challenging, by the way, mixing up the signs. So be careful with your signs, all right? So you have x minus 3 as your repeated factor, and then it would be times y plus 2. All right, so I want you all to try some for me, please. I'm writing them down. Please write down the questions, the ones that's already here, if you didn't write them down already. All right, so you're doing for me x c plus c plus xy plus y. That's the first one. The second one, you're doing xy plus 4x plus 2y plus AC. Please pay attention to your signs. Plus 4A plus EC plus 4B. Do some different signs now. XY minus 2x plus 4y minus 8 and xy minus 3y plus 4x minus 12. All right, so you're trying these for me, please. Okay, let's see. So the first one, well, number 5, sorry, was x z plus z plus xy plus y, right? So group N, you'll have z because xz and z have z in common. Z times x is xz, and z times 1 is z. And then you bring down your plus sign. X, y, and y have y in common. Y times x is xy, and y times 1 is y. So this would be x plus 1, right? Z plus y, right? Number 6 was xy plus 4x plus 2y plus 8. So the first two terms, xy and 4x, have x in common. X times y is xy, times 4 is 4x. Bring down your plus sign. 2y and 8 have 2 in common. 2 times y is 2y, and 2 times 4 is 8. So again, you see you have y plus 4 as your repeated factor. So you write that back. Then in brackets, you'll have x plus 2. Number 7 was AC plus 4A plus BC plus 4. The common factor between AC and 4A is A. A times C is AC, and A times 4 is 4A. Down your plus sign, BC and 4B have B in common, times C is BC, and B times 4 is 4B. Finally, this would be C plus 4 by A plus B. Number 8 was, number 8 was xy minus 2x plus 4y minus 8. Now, this one had different signs, so you got to be careful with your different signs. All right, so the common factor here was x. X times y is xy, and x times minus 2 is minus 2x. You bring down your plus sign. Common factor between 4y and 8 is 4. So 4 times y is 4y, and 4 times minus 2 is minus 8. So your factor, repeated factor, is y minus 2 by x plus 4. And then finally, the last one I gave you to try was xy minus 3y plus 4x minus 12. So the first two terms, the common factor there is y. Y times x is what xy, and y times minus 3 will give me minus 3y. You bring down this plus sign. 4x and 12 have 4 in common. 4 times x is 4x, and plus 4 times minus 3 gives me minus 12. So the common factor, the repeated one, is x minus 3 by y plus 4. All right, guys, that is how you would do one like that. Now, sometimes you might have a question where you don't have a common factor other than 1. So an example of that would be like if we had a squared minus ab plus a minus b, right? So I can actually go ahead and factorize right here, right? So initially, between a squared and ab, you have a as the common factor. So a times a is a squared, and a times minus b will give me minus ab, right? Now, between a and b, you do not have a common factor other than 1, and that's fine. You can actually just bring down your plus sign and you use 1. So 1 times a is a, and 1 times minus b is minus b. So you see, you still get your repeated factor. That would be a minus b by a plus 1. That's your factorization there. Right, guys? I'm going to do two more examples, and then I'm going to give you all an exercise to complete for me on the factorizing by grouping. So let's say I have 9a minus 3b minus 3ab plus b squared. All right, so let's go between 9a and 3b. The common factor is 3. So 3 times 3a gives me 9a, and 3 times b, well, 3 times minus b gives me minus 3b. I'm going to bring down this minus sign here, right? So the common factor between 3ab and b squared is b. Now, minus b times 3a will give me minus 3ab. And minus b times minus b will give me plus b squared. So guys, you've got to be careful with your signs. Okay. So then the common factor here is 3a minus b. I also have 3a minus b, the outside of the brackets. All right, let's do one more. Let's say I have 4a plus 6b minus 6a squared minus 9ab. All right, let's see what that gives me. Well, 4a and 6b have 2 in common. So 2 times 2a gives me 4a, and 2 times 3b gives me 6b. And now this minus sign here, right? Common between 6a squared and 9ab is 3. 3a times 2a. Well, minus 3a times 2a gives me minus 6a squared, and minus 3a times plus 3b gives me minus 9ab. So I have my repeated factor, 2a plus 3b by 2 minus 3a. So one thing about factorizing by grouping is that you have to be very careful with your signs, right? It's the same steps as you do with factorizing normal expressions, just like one at a time or two at a time. With grouping, it's just that you group two of them, you group it into two pairs that have like terms. Right? Now, it's very important, guys, that you understand factorizing by grouping because when we move on next week to factorizing quadratic expressions, you're going to have to use factorizing by grouping to do it, right? So I want you all to make sure you understand it. Please watch over the video if you have to, watch over this recording, or watch one of the other shorter recordings on factorizing by grouping.